Hello and welcome to Tinkerkit 6. Today we're going to build an electric trumpet, which can do all sorts of lovely and annoying tones. And we'll build on our previous lab. Let's go ahead and tear this one down. We introduce one new component in this one, the button. And we have one slight variation in this circuit from what your Tinkerkit circuit diagram actually looks like. So let's get into it, and we'll go from there. So to start, tear this down. We're going to need 2 yellow jumpers. We're going to need 1 green jumper. Going to need 1 red jumper. And we'll need 1, 2, 3, 4, 5, 6 black jumpers. We'll need our potentiometer, our piezoelectric buzzer, and 3 buttons. We're going to leave these in the breadboard this time, but we'll go over what each one is. So to start, we're going to, if you have your previous circuit still built, the piezoelectric system will be the same as the last one when you played Happy Birthday, so you can leave that in place. But I'm going to build this from scratch as if it wasn't there. So to start, I put my potentiometer with my lettering faced to the left in pins 1, 2, and 3. I'm going to take one of my black jumpers, one of the short ones, and jump from pin 1D over to pin 4F. This connects the top pin of my potentiometer into the bottom pin of my piezoelectric element. I'll take my yellow jumper, one of them, and go from 1F. And we'll bring this over to digital pin 10 in my Arduino. I'm going to take one of my black jumper wires, and I'm going to go this one from my middle pin of my potentiometer, which is 2. I'm going to use 2D, and I'm going to bring that over to my common ground rail. See if I can get it to plug in. Oh. Sometimes you gotta fight your breadboard a little bit. Okay. And then we're going to hook up the buttons down below. A button is nothing more than a power interrupt, or the ability to send power across. Now, the buttons themselves have 4 pins on them. But some of these pins are actually bridged together. So what that means is that if you put a power in here, you'll also have power out on this side. Put ground here, you'll also have ground out here. This can be convenient because we can hook up here and here and send a signal out, where we can hook up these two and send a signal out. But if you hook up side to side, this won't work. because this is effectively all on the same node, all on the same rail. So I've gone ahead and laid my buttons out so that we're bridging across the central gap there. This is the wider side so that the pins are on the sides of my buttons. Okay, I'm going to start by connecting the top pin of each of these buttons into my common ground. Okay. Now I'm going to take my red, green, and yellow jumper wires, and I'm going to go from the bottom pin of each button with the corresponding color from the button and bring them over to the side. Now there's one variation here that we're going to do differently, as MATLAB has changed something in its functional code so that the Tinkerkit you see will not work with this. And we'll get to that in a moment. So I'm going to start with the top one, the green button, the bottom pin, and I'm going to bring that down to D4. The next one, I'm going to do yellow. I'm going to go from the bottom pin of the yellow. And in this one, the Tinkerkit calls out to use digital pin 3. For some reason, the newest version of MATLAB will not let that work. So we're going to use digital pin 5 instead. Also make sure your pins are in the correct pins. So yellow is going to digital 5, not digital 3. And we'll change the code in just a minute to reflect that. And then the last red jumper is going to go from the bottom pin of the red button over to digital pin 2. Next, we just need to hook up our ground common rail to our Arduino ground, and we're good to go. Now, in the last lab, I said you could shortcut and use your ground wire here and go directly to your potentiometer, but I suggested you didn't do that because in future labs we would use the common. If you did that, make sure that you actually connect your common ground wire to the common ground and not just to your potentiometer, or none of your buttons will work. All right, so once that's going, we're going to go over to the code and we're going to pull it up now. Okay, I have my code up. Once again, I've copied this into a new script. The beginning of this is just some information that tells you a little bit about the code. From here, we start into our variables, speaker pin D10. This is the same as your last Tinkerkit. Key pins, these are some new ones. We actually create a cell array here and assign them to this one variable. So you will start it up and you'll see something that says D2, D3, and D4. These are the digital pins. We must change the second pin here from digital pin 3 to digital pin 5. If not, you will see an error like I have down below that says that it's unable to do it as digital pin 3 is in use. So once you change your digital pin 3 to 5, so it reads D2, D5, and D4. Below this, we do something different here. We configure these pins, configure pin, this is a built-in function, so our Arduino, key pins 1, so in this case it's telling it which pin on our key pin setup. We set it up as a pull up resistor. What that means is when you push the button, it expects the power to go from low to high. There's a pull down resistor, which does the same thing but backwards, so it expects it to go from a high signal to a low signal, so power to no power. That's an interrupt style. Let's go down. We start our while loop. So while 1 will run forever. Key states 1, 2, and 3. So essentially it reads the pins of each of these to see if any of these buttons are pressed. If key state 0, 1, 1. So in this case, we're looking to see if pin 0 is off and the others are on, then it will play this tone. Else if the first pin and third pin are off, but the first one is on, then it will play this tone. And our last else if pin 1 and 2 are off, but pin 3, button 3 is on, then it will play this note. And that is pretty much it for this code. You can see a note down below that has some more frequencies in here. This is useful for the going further challenge. Play around with this code a little bit, and you should be able to do some interesting things. Thank you, and we'll see you in the next one.